Hi students, this is just a short video in which I'm going to show you how to create a scatter plot on Excel, how to format it so that it presents the data quite nicely, and then I'll just do a quick demo of some of the analysis that a scatter plot allows you to do on a data set. So the first thing you'll need is to format your data set so that in Excel so that you've got your explanatory variable in a column like this, and then somewhere to the right of that you need your response variable in a column as well. It doesn't have to be directly next to it like this. It could be here, for example. It could be in this column. It doesn't matter. As long as the response variable is to the right of the explanatory variable, you'll be okay. And the reason for that is because when you make your scatter plot on Excel, Excel will take whichever variable is in the right side and put it on the y-axis. And as we know, the convention is to put our explanatory variable on the x-axis and our response variable on the y-axis. So once you've got your data set, formatted like this, let's highlight the whole data set like this, all of the numbers. I haven't bothered to highlight the column labels here because Excel often messes up the way that it imports those to the scatterplot. So I've just highlighted the data itself. Once you do that, you can go to Insert on the top here, and then you want to choose the scatterplot option from these charts here, and we know what a scatterplot looks like. It looks like a bunch of dots scattered on a plot. And then out of these options, we want the first one that looks like this. The reason we want that one is because the others do things we don't like, such as connecting the dots with lines. And we don't want that because each piece of data represents a discrete unit of data rather than all of the data being continuous like a line seems to imply. So we just want this first option here. Once we've done that, I might just move it around a little bit to make it visible. I might make it a little bit bigger like that. And now what I want to do is I want to add some nice axis labels and a chart title to make sure that a reader can tell what my chart is actually saying. So when you first insert your graph, you get these options up the top here, but if you accidentally click off and lose them, you can get them back at any time by double clicking in the chart area in a place where there's nothing going on, like this white space here. Once you've done that, you can have add chart element. You want to go there, and down to axis titles, you want to add a primary horizontal and also a primary vertical. So what that's done is it's added an axis title to my horizontal and vertical axes, or my x and y axes. From there, I'm going to give titles to my axes and also a title to my chart as well. So my x-axis, in this case here, my data doesn't really represent anything real, but an example of something real that the x-axis could be, it could be time, it could be temperature, it could be government spending. So I'm going to call this explanatory variable. And then the next thing I have to do is I need to put my units in brackets after. So if this was time, for example, I might write time, and then in brackets I'll put hours or minutes or seconds, whatever it is. But in this case, like I said, it's just explanatory variable. I'll do the same thing for my y-axis, which represents the response variable. And again, I need to put the units afterwards. Some examples of something the response variable could be is it could be my money at a certain point in time, or it could be the number of skin cancer cases compared to the average temperature in a country, all of those kinds of things. And then I need units on there. So if it was temperature, I'd put degrees Celsius. If it was money, I'd put dollars, all of that kind of thing. Very sensible stuff. Now that I've labeled both my axes, I need a logical chart title as well. And in this case, I'll call it explanatory variable versus response variable. Okay, so if this was some real life data, I might call it time versus temperature. And that would tell me that these dots here represent the temperature of something as time increases. Cool. Now my scatterplot is formatted quite nicely. I can start to do a bit of analysis on it. And also, if I was to show it to other people, because it's labeled, they could verify that analysis, or they could do some analysis of their own, because it would start to actually make sense. What is being represented here once my x-axis and my y-axis are labeled? So something I can do to start my analysis off is I could add in a trend line. And the way that I want to do that is I want to add a chart element, go down to trend line, and in general maths, we really only work with linear trend lines. There are other options that could be nicer for this data set. As you can see, the exponential one fits it quite nicely, but I've purposely chosen something that isn't nice and linear here just to show some limitations of trend line analysis. But anyway, the way that we put the trend line on there is to add the chart element, go down to trend line, and put a linear trend line on it there. Once I've done that, I also want to double click on the trend line like I've just done. And if I scroll down in the options here, I want to display the equation on the chart and display the R squared value on the chart. So the equation of my trend line is shown here. That's something we're going to go over a little bit more in chapter 2. There's some analysis on the trend line itself that we can do, the equation of the trend line itself that we can do with our chapter 2 knowledge. But R squared is something that we've looked at already. And we can see from this R squared value and also from the line itself on my scatter plot here, that this trend line isn't actually a very good fit for my data set at all. So there's some things to talk about here. And in my analysis, let's just focus on direction, form, and strength for now. So looking at the data itself, the scatter plot, rather than just the trend line, I'm going to look at the smattering of points rather than the trend line, because the points are my real data. This dotted line here is my trend line. The real data is the most important thing. The trend line can help us do some analysis, but the real data is the most important thing. So the direction of my relationship here can either be positive or negative or sort of neutral or no direction. And I can see that as the x-axis increases, so as we go further to the right, the points tend further and further upwards. So because they're going upwards as we go to the right, the direction here is positive. Now form here, if I was to just look at this trend line only, I would say linear. Okay, but looking at that trend line only is a mistake, because it's this data set that we want to look at. It's the dots on my scatter plot that we want to look at. So looking at those dots, I can either classify the form as, in general maths, the form can either be linear or non-linear. And looking at how it really doesn't fit this straight line, I'm going to have to say that the form of this relationship is non-linear. Okay, if I had some knowledge from a higher math subject or from some further studies into bivariate data, I might say that the relationship is exponential or quadratic or something like that. But with what we've taught you, we really only expect you to classify it as linear or non-linear. So the fact that it doesn't fit that straight line trend line, that helps me to say it's not linear. And I could also use this R square value that isn't high, it's only 0.56, which is sort of a moderate strength of linear relationship. Both of those allow me to say that this is a non-linear form. Finally, the strength, I might be tempted to look only at the R squared value to tell the strength of this relationship. And if I was to do that, I would say 0.56 would be a moderate strength. But the mistake there is that this R squared value is only rating the strength of the relationship between this trend line and the data set here. So it's essentially telling me how suitable is a straight line for representing my data. And it's only moderately suitable. It's not telling me what the strength of the correlation is. It's telling me what is the strength of the linear correlation. So there's a moderately strong linear correlation. However, we've said that this form is clearly not linear, and if we look at that non-linear pattern, the sort of exponential pattern that we've got going here, it actually follows the pattern very strongly. I could draw a line through these that the data is very tightly packed around. So because of that, I will actually say that this is a strong relationship. So I can trust that my explanatory variable and my response variable are quite strongly correlated here, despite the fact that they don't match the trend line and the R squared value is not high. Because like I said, those kinds of things can be a red herring if the data is not linear. So thank you very much.